When we think of the consequences of burning fossil fuels, the immediate focus is almost always on carbon dioxide, that emissions as CO2, and their role in driving climate change. However, in the fundamental chemical process of combustion, another crucial molecule is consistently produced: water, H2O. Fossil fuels, coal, oil, and natural gas are fundamentally hydrocarbons, molecules composed primarily of hydrogen and carbon atoms. The act of burning these fuels is a rapid chemical reaction with oxygen in the air. For complete combustion to occur, every carbon atom in the fuel must find two oxygen atoms to form CO2, and every hydrogen atom must find one oxygen atom and form H2O. The chemistry of combustion. The most straightforward example is the combustion of methane, CH4, the primary component of natural gas, CH4 plus 2O2 results CO2 plus 2 H2O. H2O. This equation reveals that for every single molecule of methane burned, two molecules of water vapor are released into the atmosphere alongside one molecule of carbon dioxide. Similarly, burning liquid fuels like gasoline or diesel, which contain longer chains of hydrocarbons, yields substantial amounts of water in the form of vapor. Coal contains less hydrogen by uh, mass than oil or natural gas. It still produces water vapor during combustion. This water vapor is often visible as the white plume emanating from power plant cooling towers or the exhaust of a car on a cold day, where the hot vapor condenses into tiny liquid droplets upon meeting the cold air. But it's a drop in the ocean that enters the water cycle context. If the combustion of global fossil fuels generates billions of tons of water vapor annually, why do scientists not raise alarms about altering the water cycle or causing sea levels to rise directly from this production? The answer lies in perspective and scale. The amount of water generated by human activity pales in comparison to the natural scale of the Earth's hydrological water cycle. The total volume of water on Earth is vast, estimated at around 1.4 times 10 to the 9 cubic kilometers. The natural water cycle circulates massive quantities of water constantly through evaporation, condensation, and precipitation. It is estimated that the sun evaporates approximately 5 times 10 to the 5 cubic kilometers of water from the ocean and land every single year. The amount of water generated annually by global fossil fuel combustion is estimated to be in the order of hundreds of cubic kilometers, significant by human standards but minuscule compared to the natural uh, 500,000 cubic kilometers circulated by nature each year. And it stays in the atmosphere temporarily. Unlike CO2, which lingers in the atmosphere for centuries, the injected water vapor is a short-lived atmospheric component. It integrates seamlessly into existing weather system. Water vapor is the Earth's most significant natural greenhouse gas, but the amount added anthropogenically is quickly cycled out of the atmosphere through precipitation, such as rain and snow, within days or weeks. It doesn't accumulate over time like the stable, long lived greenhouse gases that are the primary drivers of climate change. Water is an unavoidable product of energy generation via fossil fuels. Chemically, its production is essential to balance the combustion equation. Environmentally, While the volume of water produced is large in absolute terms, it constitutes a mere drop in the ocean within the context of the vast dynamic natural water cycle. The critical environmental impact of fossil fuel combustion remains the persistent accumulation of carbon dioxide, uh, which disrupts the Earth's energy balance and drives long term global warming.